Hello everyone, welcome to our session Securing Azure Arc Data Services. My name is Mélony, a program manager at Microsoft in Azure Data Team. For the last 20 plus years, many customers have been successfully growing their businesses with SQL Server. Nowadays, more and more organizations are actively migrating to the public cloud, like Microsoft Azure. However, data sovereignty and legacy concerns are slowing down their progress. Azure Arc-enabled SQL Managed Instance makes it possible for these customers to take advantage of the key capabilities of SQL Server or DBMS engine have to offer, while storing their data on premises in private data centers such as Azure Stack or Azure Stack HCI, or in multi-cloud environments, while providing better manageability and lower maintenance cost. So in this session, we'll talk about the security aspects of Azure Arc-enabled data services. We'll take a look at key security features and capabilities of Azure Arc-enabled SQL Managed Instances versus SQL Server. From there, talk about a certificate for transparent data encryption, TDE, and how it works when it comes to Arc-enabled SQL Managed Instance. Also, have a quick look at the deployment permissions to help you start deploying Azure Arc-enabled data services. Then dive into authentication and authorization of Arc-enabled SQL Managed Instance. If you are ready, let's get started. When we're looking at all popular security features provided by SQL Server, Azure Arc-enabled SQL Managed Instance has a great level of priority thanks to the fact it shares a common code base with SQL Server on Linux. Key security features such as transparent data encryption TDE, which is also known as encryption data at rest. It encrypts SQL Managed Instance data files. Same as SQL Server, SQL Managed Instance also enabled column-level encryption and row-level security. Dynamic data masking helps prevent unauthorized access to sensitive data. As for the auditing, we have a basic and fine-grained auditing to keep tracking and logging events that occurred on a database engine. So down below, check out the article showing the key features and capabilities of Azure Arc-enabled SQL Managed Instance by aka.ms/arc-SQLmi security. When you get started to deploy a new SQL Managed Instance, we must ensure we have proper permission to kick off the deployment. For Azure Arc-enabled SQL Managed Instance, we have direct connectivity mode and indirect connectivity mode. For direct connectivity mode, we use Azure Arc to assign role permissions in Azure Active Directory to control authorization checks on the Arc-enabled Kubernetes cluster. The API server of the cluster is set to use webhook token to authenticate and authorize requests. For indirect connectivity mode, we align with Kubernetes Arc to deploy Arc-enabled SQL Managed Instance. The Kubernetes authorization is handled by cluster role bindings and role bindings, so it follows the best practice of Kubernetes Arc. In this scenario, the authentication request goes through the Kubernetes API server, where it is recognized as REST operations, and the API server validates the request for the API objects, such as paths, stateful sets, and so on. In between, we have configured Kubernetes native dynamic admission control by using admission webhooks for extra security controls. Also, notice that we are following the principle of least privilege by running your containers as run root. It prevents malicious code from getting permissions in the container host. When it comes to certificate, Azure Arc-enabled SQL Managed Instances use Transport Layer Security (TLS) to encrypt data that is transmitted across a network between a client application and a SQL Managed Instance. Arc-enabled SQL Managed Instance supports rotating TLS certificate provided by the user in indirect mode. You can use your CA or auto-signed certificate using OpenSSL. We provide manual certificate rotation through Azure CLI or Kubernetes native way, which is kubectl. The setup process is a similar experience to SQL Server, but the kubectl is easier to be integrated with your DevOps pipeline to automate the rotation process. To know more about certificate rotation, check out the link here down below, ArcSQLmi certificate. When it comes to authentication and authorization, Azure Arc-enabled SQL Managed Instance also provides a consistent experience as we enabled for SQL Server in the past. More specifically, Arc-enabled SQL Managed Instance supports basic authentication, which is known as SQL logins. With SQL logins, you can use username and password to connect to SQL Managed Instance with limited permissions. Users are specific to each database, and they must be separately created in each database to grant them access. For the past many years, Active Directory authentication for SQL Server is one of the most important features. It's also one of the most popular requests for Arc-enabled SQL Managed Instance. In particular, from our security-sensitive customers, it fits in well within the organizations in hybrid identity scenario. AD authentication is also known as integrated authentication in SQL Server. It is Kerberos protocol-based authentication. It allows to verify the identity of a user or a host computer within the network. With AD authentication, it enables domain joined Windows or Linux clients to authenticate to SQL Server with their AD domain account. Basically, users authenticate via single sign-on without being promoted for password. So each user has a single identity across your organization, so you don't have to keep track on which SQL login corresponds to which people. AD enables you to reinforce a centralized password policy across your organization, where you can set up password complexity requirements, so people can choose a compliant password for their AD account, or decide how often those AD users are going to change their passwords. Let's talk about a little bit more about AD authentication. SQL Server was known as a traditional Windows-based data platform. However, since SQL Server 2017, we brought it to the Linux world. SQL Server, as a comprehensive data analytics platform, is now officially to be capable of running everywhere. In Windows, we could configure a Windows Service account to run processes. When it comes to Linux or Unix systems, we need a Keytab file to automatically log into Active Directory on the startup. Therefore, we use a Keytab file to enable AD authentication for SQL Server on Linux and Linux containers. Speaking of which, the Keytab file is a cryptography file containing service principal and host names. So we need an AD account and register SPNs under that account. Then we can use tools such as ADUTL, KTUTL in Linux, or KTPass in Windows to generate the Keytab information based on the provided AD account SPNs and the DNS host information. In December 2021, we enabled Azure Arc-enabled SQL Managed Instance in Active Directory authentication with Customer Managed Keytab (CMK). It allows customers to create and manage their own Keytab file. Lately, we also enabled a System Managed Keytab (SMK) to help customers simplify a set of manual steps such as AD account creation, Keytab generation, and set up DNS records. So imagine if you are a DevOps engineer or a system admin or a SysOps engineer, looking at the user journey just from a user point of view, where you can see you need to create a data controller, then deploy AD connector. Finally, you can deploy your Arc-enabled SQL Managed Instance. So in a nutshell, when we're looking at a System Managed Keytab or Customer Managed Keytab, a few steps are on setting up an AD account, registering the SPNs, or setting up DNS records. For the Customer Managed Keytab, we can see we allow customers to bring their own Keytab file. Therefore, more specifically, if we compare those two modes, customers who are familiar with managing Active Directory may choose CMK, the Customer Managed Keytab, because that gives them flexibility in their automation process. Other customers may want a highly automated AD management experience, so they probably will go to System Managed mode. In a Customer Managed mode, it's up to users to provide a pre-created AD account and register service principal under the AD account, and therefore they need to generate a Keytab using the tools of their choice. In a system manager mode, users only need to provide an organizational unit and then a domain service account. This account needs to have sufficient permissions on the OU level in Active Directory. So the sufficient permissions could be create AD account, delete AD account, etc. We have documented the permissions so you can have a look. And with that, the system will generate a domain service account for SQL Managed Instance. And this is an automatic process. Then we also will set as SPNs automatically on that AD account. And from there, the Keytab file is generated and it is delivered to the SQL Managed Instance. So the instance can use it every time when it needs to talk to the LDAP server. Just looking at the experiences here, we also provide a manual Keytab rotation experience when it comes to customer managed Keytab. And for system managed Keytab, including the Keytab generation and rotation experience are managed by system. So now let's look at the deployment experience of a customer managed Keytab mode. First of all, we need to have an organizational unit. So for those who are familiar with OU is a container within an Active Directory domain, which can hold users, groups, and computers. With the OU, an admin can assign group policies or account permissions. So let's go to see my VS Code. So this is the aforementioned to create an OU here. So from here, you can create an OU or a new user. And you can do this from the UI or from using script like I did here. And then you need to register SPNs under that account. So the process can be automated by PowerShell script, or you can choose, for example, using your UI to do so. But most organizations, they have a highly automated process. So this script can be used in a scenario. After we created a OU under Arc user, which is a service account, where we can create a Keytab for SQL Managed Instance to use. And here, actually, we provide a script based on ADUTL and KTUTL. It runs on Linux. You need to provide the account name and DNS information. Therefore, we will create the Keytab for you. So here you can see the name of the Keytab file is called Arc user Keytab. And then because the way we consume the Keytab file is to create a Kubernetes secret, therefore we give the Kubernetes secret name as well as where we deploy this secret. Of course, you can also use your ADUTL or KTUTL to do so to create a Keytab. And in Windows, you can use KTPass. If you want to have a look at what it would look like in a secret, so basically this is a classical Kubernetes secret where you put a secret name, which is the same as in a script. So, but you can define your own, and you only need to put the Keytab information in the body. So, which we can see here, data and Keytab. This is the cryptography file of Keytab. So this is the information in the Keytab file, where you can put in a secret. Then you create a Kubernetes secret in the same namespace where you're gonna deploy your AD connector. So let's go over the process to deploy the customer managed Keytab to enable Active Directory authentication for SQL Managed Instance. Firstly, we need to deploy the data controller. This is no different from other deployment. Data controller is the same experience. And here, using the indirect connectivity mode. So this script works on the kubeIDM. After I create a data controller, the key thing is to deploy the AD connector. AD connector is a custom resource. Custom resource is a Kubernetes definition. So basically here, what we created is a AD connector, and then we only need to put in the DNS information for IP address of a DNS server and the domain controller information in the body here. So basically here is where we enable the Active Directory authentication, and we prepare an environment here where you deploy your very first SQL Managed Instance. if you are going to enable AD authentication, you only need to put in your security part where we have Active Directory section. Here you can associate the AD connector information here. So basically where we can hear this is the AD connector, the name of the AD connector, and in which namespace we deploy the AD connector, as well as the account name. This is the AD account name which will be used by SQL Managed Instance, and it's the same which we saw earlier in the script. As well as the Keytab information. This is the Keytab information we saw earlier when we defined a Kubernetes secret. It contains the information of this AD user account as well as SPNs plus the DNS information, and it's all encrypted. So in this section is where the magic happens when you deploy the SQL Managed Instance. You may also notice in the security section, we have Active Directory. We also have an admin login secret. So this is where we define a secret to provide the basic authentication. So which you can see actually I want to simplify experience. Therefore, I already defined another secret in the same YAML file, just group them together. So here I defined a secret called Arc-enabled login secret. So here I provide a username and a password. This is the basic authentication logins I provide for SQL Server. So after you deploy the SQL Managed Instance, you can use the basic authentication to log in. And from there to create AD users and AD groups to assign the right permission, and therefore you can enable AD authentication. And after that, you can log in with AD account without any password promoted. From the above demo, we know the importance of the Keytab file. It is a security-sensitive information, so you might think of securing Keytab information using a Vault solution, such as Azure Key Vault, or any third-party Vault solutions, such as HashiCorp Vault. Here, we'll have a look at a demo about how to read Keytab information from Azure Key Vault. First thing first, Azure Key Vault is a cloud service for securely storing and accessing secrets. A secret is anything that you want to tightly control access to, such as API keys, passwords, certificates, or cryptography keys. So in this demo, we'll be showing how to use Azure Key Vault secret client library for .NET to read Keytab information from Azure Key Vault. So firstly, I will go to Azure portal. I have Azure Key Vault already deployed. So I stored Keytab information in the secret section, and you can see I actually have a few information here. So one of them are the Keytab information. Let me click on that, and you can see in the Key Vault they actually have this notion of versioning. I will choose the latest version. And from here, I can see for each secret, I have an identifier. So this is the URL very interested in us. So it's where we store the secret. And if you can click on, you have enough permission here, you can see show secret value, where it contains the value of the Keytab. So this is the same when we saw in the Kubernetes secret body. It's the same information. So what I'll do now is to use a C# program to read the Keytab information from Azure Key Vault. Let's go to my Visual Studio. So here is a C# program mentioned before, where I need to put the Key Vault URL here. I defined the service principal and secret here as an environment variable. So actually, I have 3 different environment variables here. And another way actually here is we can enable the managed identity of the Key Vault. So from here, you can see I use the secret client. Here, I need to initiate by putting the URL of the vault. Then I can define to get a secret here using a very simple client method, which called a get secret. So the Mélony Keytab here is where we define, we store, this is a key pair value. So the key of the value of the Keytab is a Mélony Keytab here. So here, then I will be able to read the name of the Keytab and the value of the Keytab here. So if I do launch by program, so I can see here I initiate an instance here, and then go to the next step. Just make sure everything's good. As I said, this is store is a key value pair, so I have a Mélony Keytab. So correspond to this key, we have the value of the Keytab, which I will show you in a second. So the Keytab value is what we saw from the portal, and this is encrypted information, contains the service principal names plus the host names. So this is used by SQL Managed Instance every time when I talk to the AD domain controller. I'm trying to print out this information here. So as you can see on the screen here, this is the Keytab information I read from Azure Key Vault, which of course, aside from Azure Key Vault, you can also use HashiCorp Vault or other solutions. It's very similar, and it's really up to your use case to make your decision. As we mentioned, the Keytab management, including a set of manual steps, it's a differentiator between the customer managed Keytab and the system managed Keytab mode. So here we'll be showing also how to enable AD authentication in SQL Managed Instance using a system managed Keytab mode, where we manage a Keytab generation, rotation, and some other key things. So in this demo, I'll be showing how to enable AD authentication for SQL Managed Instance in System Managed Keytab mode. First thing first is to deploy a data controller. So it's very similar. I pick up a AKS profile and choose the namespace where I'm gonna deploy my data controller. I need also to provide the ID of my Azure subscription, as well as put some username and password for monitoring. Here I use intra-connectivity mode, where I used to specify the flag use Kubernetes. After deploying the data controller, I need also to deploy the AD connector. So AD connector is an important component to enable AD authentication for SQL Managed Instance. And here you can see I have two YAML files, group them together to create an AD connector. In AD connector, we can see the difference between the system managed mode to customer managed Keytab mode, as we have the Active Directory section where I have the service account provisioning set to automatic. This means I will take care of AD account creation as well as SPN's registration and plus the Keytab generation, the whole process. Where I need to specify the OU distinguish name, which contains the OU as well as my domain controller information. The same as we did for customer management mode, we also need to provide the domain controller information here, the host name as well as DNS IP addresses. As you can see, I grouped another secret which is used by the DSA, which is domain service account. So this is AD account with specific permissions, which allows to create an AD account, delete AD account. So this account will create a AD account for SQL Managed Instance. Therefore, here, if I deploy this YAML file, and when we deploy the SQL Managed Instance, in the section, it's the same as what we did for customer managed mode. Basically, we need to provide the information for AD connector. By providing a name, we associate AD connector with SQL Managed Instance. And the account name, this is the account will be used by SQL Managed Instance. And in System Managed Keytab mode, we will create this account in Active Directory for you. Also, similarly, we deploy another basic authentication logins here, just to group them together. And in the section, we provide as an admin login secret here. So after we deploy this SQL Managed Instance, we can provide a basic authentication login, connect to the endpoint, then we can create AD users and logins from there. So after you enable AD authentication for Arc-enabled SQL Managed Instance, you can connect to it using the SQL logins to create AD groups and users. It's the same experience as other versions of SQL products. You can do this by leveraging the same T-SQL syntax, such as we are showing here, grant, deny, and revoke. You can create a SQL logins and then connect to the SQL Managed Instance. And from there, when you create the logins for AD groups, then you can manage access and permissions in SQL Managed Instance using AD group memberships. So this is the same experience as you did before with the SQL Server. And here's an example showing you how to do that. It's the same T-SQL syntax. Thanks for attending our session today. Here is some references that will be helpful if you want to deep dive later. Please feel free to feedback us on our official channel and check out other Azure Arc-enabled data services sessions on the topic if you are interested. Thanks everyone. Have a wonderful Microsoft Build 2022 conference.